Hello, everyone. Can I have your attention, please? Okay, thank you for coming to this session on virulence factors and pathogenesis. We have 4 presenters for this session, and I happen to be the first person to present on the title, In Vitro Evaluation of Enzymatic Virulence Activities and Antifungal Susceptibility Profile of Microsporum canis from various sources. Seeing the clinical picture there and the microscopy, as we all know, Microsporum canis is a zoophilic dermatophyte. It is characterized by multifocal alopecia, scaly and secular lesions, and these lesions are similar to other dermatophytes. Microsporum canis is one of the major pathogenic and most prevalent dermatophytes found in domestic animals and humans. In humans, this is presented as tinea capitis, tinea capitis, and is also known as ringworm. Pathogenesis of this infection is associated with the secretion of virulence factors. There are a lot of virulence factors which help in the pathogenesis of this infection, and keratinase happens to be the key enzyme. There are also other enzymes that occur at different frequencies, varying between the species and hosts and pathologies with scant correlated results. Although there are many studies on enzymatic activity of dermatophytes, there are many of them that have been conducted over the years, but there is lack of enzymatic profile of M. canis. Catalysts, hemolytic factors, and thermotolerance have been well described for yeast and molds, causing human and animal skin infections, but they were not well investigated for Microsporum canis. So, Microsporum canis infection might be very severe and difficult to treat in hosts whose immunological system is impaired or even in immunocompetent ones. However, azoles and terbinafine has been the most commonly available drug for the treatment of this infection. But recently, we've had azole and terbinafine resistance documented, but Microsporum canis resistance to this azole and terbinafine is very rare. What are the aims of the study? In this study, we aim to assess the capability of Microsporum canis strains to produce enzymatic activities. And we also evaluated the in vitro antifungal susceptibility profile of this Microsporum canis strains. We also assessed the relationship between the virulence factors and the low susceptibility of Microsporum canis to antifungal drugs from different hosts. We also assessed the relationship between virulence, antifungal profile, and occurrence of skin lesions. A total of 1,100 Microsporum canis strains from southern Italy were obtained, and we divided it into animals with lesions, animals without skin lesions, and humans. These strains were subjected to phospholipase, lipase, hemolytic, catalase, and thermotolerance activities. Excuse me. Sorry about that. Okay, for the antifungal susceptibility testing, we used the conidia suspension to do this, and we prepared the conidia according to previously reported work. This is like harvesting the colonies, sedimenting them for 15 minutes, and we filtered with Wattman filter paper. So looking at this picture, we have only the macroconidia being gotten from the mixture, and then we used we did drug dilution of 7 antifungal agents. From the results, we have a total of 94 Microsporum canis and 92 strains that showed phospholipase and hemolytic activities, respectively. And also, we discovered that Microsporum canis strains showed lipase, catalase, and thermotolerance activity. Looking at this study, there was no statistical differences between the occurrence of phospholipase and hemolytic values of Microsporum canis strains from animals, despite the different groups they belong. And then we also observed a statistically significant difference in the lipase values. And also, we saw that the lipase values were lower in strains without skin lesions than those from with lesions and from humans. Okay, and also we discovered that there was a statistically higher catalase activity that was registered with animals with skin lesions and humans with tinea corporis than those without skin lesions. The number of Microsporum canis strains with low thermotolerance was statistically higher than those with high thermotolerance. Thermotolerance of this Microsporum canis never varied according to the source of this Microsporum canis strains. In the antifungal susceptibility test profile, we discovered that voriconazole, terbinafine, and posaconazole were the most active drugs, followed by ketoconazole, grisofulvine, itraconazole, and fluconazole. The MIC values from animals without lesions were discovered to be lower than those in animals and humans with skin lesions. The itraconazole, fluconazole, and ketoconazole MIC ranges were lower in animals without skin lesions. And also the voriconazole, posaconazole, and grisofulvine MIC ranges were lower in humans than those in animals with and without skin lesions. This is a table from a helicopter point of view. You can see the correlation between the virulence factors and the minimum inhibitory concentration of 7 antifungal drugs. In this table, we had to divide it into low susceptible and high susceptible strains using the MIC 90. From the table, we saw that there was no statistical difference in the production of virulence factors between the strains with low or high susceptibility to ketoconazole, posaconazole, and terbinafine. And also in animals with skin lesions, we also saw that the hemolytic and the catalase activities varied in terms of the low or high susceptibility. A low catalase activity was also registered in the low voriconazole susceptible Microsporum canis strains than those registered in the high susceptible ones. In animals without skin lesions, a statistically higher lipase activity was registered in high susceptible ITZ Microsporum canis strains. We also saw that Microsporum canis strains with high thermotolerance had low susceptibility to antifungal drugs. So from this study, we saw that phospholipase, hemolysin, catalase, and lipases are part of enzymatic factors of Microsporum canis, which favors its survival in host tissues. We also discovered that the production of phospholipase is not linked to the occurrence of skin lesions. We also saw that the high value of catalase registered in strains from the animals and humans with skin lesions may suggest that these enzymes favor the occurrence of skin lesions. Also, voriconazole, terbinafine, posaconazole happen to be the highest, the ones with highest antifungal activity against M-canis strains for all the groups, suggesting them as the drug of choice for treatment in both human and animals. The finding that voriconazole, posaconazole, and grisofulvine were lower in animals, in humans than in animals might be due to the pharmacokinetics and pharmacodynamics properties. So since the MIC values varied amongst hosts with and without skin lesions, being higher in hosts with skin lesions, their correlation with virulence factors may be linked to the appearance of skin lesions in animals and humans. So the significant positive correlation of voriconazole, fluconazole, and glycofulvin values seen in the hemolysin and catalase production suggests that these enzymes, both the enzyme patterns and antifungal susceptibility, play a significant role in the occurrence of skin lesions. In conclusion, the clinical isolates of Microsporum canis from different origin, we all know, produce enzymes at different levels of activities. The profile of the virulence enzyme might be dependent upon factors related to the host. And also the relationship between each enzyme and the occurrence of skin lesions in animals with and without skin lesions, and also humans, varies, and only catalase and lipase seems to be correlated with the strains of Microsporum canis, from being a commensal to its pathogenic level. High catalase and low lipase activity seems to be correlated with the occurrence of skin lesions. So the antifungal profile associated with enzyme pattern are also important to explain the evolution of pathology caused by Microsporum canis. Grazie mille. Thank you. I don't know, do we have questions from the floor before we go to the online questions? Okay. Are these results already published? Not yet. We are still working on the manuscript. We are yet to publish the results. Thank you very much for that question.